Okay, good evening, everyone. Okay, welcome to our show tonight. Okay, we have this session. Actually, it's quite an ad hoc, last-minute decision to have this session in conjunction with the International Observe the Moon Night, which is 26th of September internationally. Okay, so for tonight, we are going to talk about the moon. Okay, basically, we will look at some basic I would say the tips and guidelines in observing the moon, and then later we will look into imaging the moon. Okay, how can we take a picture of the moon? Okay, and maybe some tips, okay, from our professionals, okay, or to take a good image. Okay, so today we are together with Dr. Chong, which is the president of our Astronomical Society of Penang. Then we have our good friend William Chin, okay, from KL, from the Starfinder Association. Okay, and then we have our Dr. Derek Lim from Thailand, okay, which is actually Malaysian. Okay, so he's also a major astronomy enthusiast. Okay, so let's start tonight.
Yeah. Okay, first of all, I will introduce the coordinator, Michael. So Michael and I, we are in Penang. Okay, William, of course, is in KL, and Derek is in Thailand. All right. So this is actually like what Michael mentioned just now. It's an ad hoc basis. But I think it's relevant that we should do it because this is actually International Observe the Moon, what we call for 2020. So NASA has been organizing for the past few years. So this is for 2020. All right. So and then basically what we know is if we check on their main website is that NASA is actually preparing the people of the world for what the next moon landing of the Americans on the moon, the Artemis program 2024. But I think the deadline of 2024 to land a man and a woman on the moon looks like a bit ambitious, but that's what they are proposing. So next year, Artemis 1 will be unmanned, what they call a rocket go around the moon. And in 2023, will be have two human beings will try to loop the loop around the moon and come back to the Earth. All right, like Apollo 8. Which went around the moon and come back. Didn't land on the moon. Because Apollo 11, they landed on the moon. So in 2023, when Artemis will go around the moon and come back with two astronauts, it's only in 2024 that they plan to have a man and a woman on the moon. But that looks very ambitious. So basically, they're preparing the world, the people of the world, to be more interested on the moon. Right? So let's say if you go to what they call this information, like what our Michael sent to me earlier. Okay, so tonight, change up it. 11 days of the moon. And ladies and gentlemen, boys and girls, please look at the moon. It's going further and further. Why? Because now the moon is going towards its apogee. The lunar perigee was on September the 18th. Perigee means the moon was very close to the Earth on September the 18th. So it looks very big, the moon looks from the Earth. But now it's going further and further away. So the moon's apogee will be on October the 3rd. So every moment now, the moon is going away, So even after this session of maybe 1 hour, the moon will be thousands of kilometers away from the Earth. So please look at the moon. It's going to be further and further from the Earth and become the furthest away, smallest on October the 3rd. And afterward, it goes in a cycle back to perigee, right? So basically, for those who are new, you look at the moon, hey, like this, right? So we know that the moon is a natural satellite of the Earth. And we are so lucky that Earth got at least one good natural satellite. But these planets like Mercury and Venus don't have any moon. So any aliens on them, sorry, no moon. At least we have one moon. But those are the very lucky aliens if they are on Saturn, Jupiter. They have many moons on Saturn and Jupiter. But we have one, so no problem. So basically, if you have a very, what they call, now you can buy an ordinary cameras, compact camera, which has a very, very big zoom, You can zoom, you can actually get a picture of the moon like that. Of course, you put in a telescope, you can see the, what you call, small part of the moon and large. So this one is, Michael, can you hear me?
Can.
Okay. So if you have a good compact camera with the zoom, you see the moon like that. So when you see the moon, you got black patches and white patches. So we know the black patches are the so-called mare. All right. So mare is a Latin word for the sea. All right, the sea. And then the plural for the mare is a Maria. Not Marias, with an S. No S, no. M-A-R-I-A. Maria means many seas. So you can have actually you can get what's called moon map. So with the moon map, you can refer to it. So for example, you have here the Sea of Crisis. All right. Don't say, oh, this is a small patch.
Dawson, are you sharing your screen?
Oh, okay. Wait, let me see.
Yeah.
Wait, let me see. I don't see the sharing screen thing.
Yeah. Bottom right.
Bottom right. Wait, let me see.
Present now. Yeah.
Okay, let me see. I don't see it.
Bottom now there is a
no.
present
no.
now. Yeah.
Okay, now your entire screen. Sorry,
Yeah.
Thanks for the reminder. Can you see now?
Yeah, can.
Okay. So now you will see with your ordinary camera with the zoom, or of course with a telescope, you can see the moon like that. So this is the 11-day moon tonight. So basically you see here dark patches and the white patches. So for ordinary people, they say, what are all these black patches? So the black patches are called the Maria, the seas. The first thing that people will hear, they say, got water on the moon. There is water on the moon, but not here, not in the Maria, because when the Europeans invented the telescope in 1609 by Galileo, they look at the moon, they see all this, they thought the moon got sea, got water. Actually, it's not. So actually, this Mare singular Maria is actually where from the mantle. Remember, just like the Earth, you have a thick crust on the Earth, and below the crust you have the mantle. So the moon also has a crust, and below it you have a mantle. So many years ago, billions of years ago, when the moon was younger, the molten lava, basaltic lava, basic type of lava, that erupt from the mantle and come up to the moon surface and flooded these areas here. And now you have this like flat region, dark region. All right. Okay. The earlier part, when even before the lava was flowing out from the mantle into the moon surface, this part was what? This was actually impact craters of big asteroid hit the moon, and then there was a big hole on the moon surface. And later on, the magma, the lava from inside the moon will flow out and fill it like that. And later on, you will see more craters will fall. So it's not true that all the lunar seas or the Maria are very smooth. If you go very close to it, it's full of small craters. So for those who are new to the moon, don't imagine that, oh, this is the Sea of Crisis. And this is, of course, Mare Crisium in Latin, but I use the English name, Sea of Crisis, Sea of Fecundity, that means very fertile, Sea of Tranquility, where Apollo 11 landed. So Apollo 11 landed somewhere here. Near the edge of the sea and also the mountain here, Apollo 11, and Sea of what do you call Serenity. And here is Oceanus Procellarium, Sea of Storm. So don't think that some of you are new to the moon. Oh, this Sea of Crisis is like you go to position, you are in KL, go to position, you step on a dish and make a hole in the sand. Oh, this is the hole in the sand. No, it's very big. Again, we'll put the whole of Malaysia inside. So huge part, the sea. All right. And then you have all this, what they call the brighter part is what? The mountainous region. So basically the moon has mountainous region and valley also. So if you enlarge it, for example, you can see that you have mountains and valleys also. And this is a big crater here. They call it Tycho, all right, named after a Danish astronomer. So basically is that you have mountains and valleys of the moon, and also you have craters here. For example, there's a crater here, Copernicus, named after the Polish astronomer Copernicus, the guy who proved that the sun is the center of the universe, not the earth, all right? The heliocentric model of the solar system proposed by Copernicus. So this is named after him. So he deserved it because it's a big crater facing the earth. So you have on the moon, you have the mountains, the valleys, the craters, the sea, and so on. So actually you can go to some of the NASA database. So in the catalog of the moon, by Homo sapien, by human being, there are actually millions of features on the moon. But sorry, this is part of the moon facing the earth. All right, the near side. Okay, the other side, I don't use the not so nice sounding word. I use the word the far side. So the far side got more craters and less sea. So on the far side is many craters, only 3% are the seas. But on the near side facing the earth, many of them are the seas. So if you look at this part, this is the northern part of the moon. This is the south. and this is the east, and that's the west, right? That's it. And then, of course, many people ask us, is there water on the moon? There's no water. But in the past many years, especially the American lunar orbiters have detected with proof that in the North Polar region and the South Polar region, there is frozen ice on the moon. For example, in the South Polar region, if the Artemis program comes through in 2024, the number one candidate site is the South Polar region on the moon, where you have the rocket will land down and you go to the crater, and you remember the craters in the South Pole, so some parts of the crater are in permanent shadow of the sun, permanent shadow, and you find that it's very, very cold. So you can have, they suspect there are a lot of water there frozen there, and they have detected, for example, there's still this LRO, Lunar Reconnaissance Orbiter, still orbiting around the moon, and detected without any doubt that in the South Polar region, North Polar region, there is water, hydroxyl radical. There is water, right? So that's where they are going to land, all right? So basically, if you ask me, is the moon a kind of mystery to the Earth many years ago? No, the moon is very well known. It's just like, say, have you been to Tokyo? Yes. Have you been to London? Yes. So just like human beings, they know so much about the moon. Of course, it doesn't mean that they have been to the moon to know the moon. Only 12 human beings have been to the moon. The 6 Apollo mission, each mission two muscle men. So 12 muscle men have been to the moon. But the rest of humanity, you can look, you can have so much data of the moon. The moon is no more a mystery, right? So basically, why it's so important for us to know what the moon is. In a sense, I put a big picture of this tonight's discussion is the destiny of man in the solar system depends on this object. What is the object? The moon. Because if man wants to go and explore Mars, like what Elon Musk is trying to do, and also other people like Jeff Bezos and so on, and later on after going to Mars, they're going to explore and exploit the resources of the asteroid belt and explore the whole solar system, right? And hopefully in future, man colonization of the solar system. This talk's very big, but this is actually being described by many science fiction authors for many years, and NASA is very keen on it. So the stepping stone to go to the Mars, other planets, and explore the solar system is through the moon, because the moon gravity is very, very weak, 1/6 the Earth's gravity, and very close to the Earth, only about 380,000 kilometers. So if you want to go to Mars directly from the Earth, too much trouble. You have to go to the moon there, form a kind of a permanent moon base, and then from the materials on the moon, you build your rocket, your industry, and then from the rocket, from the moon, you go to Mars and eventually explore the solar system. So that's it. So that's it. Anything I missed out, Michael?
Okay. So how about the...
Okay, just one more thing. So the main difference of the moon, of course, the moon is much smaller. I don't want to give you the numbers. So in other words, in terms of the mass, the moon is about 1/80 times smaller than the Earth in terms of mass. Right? So imagine the Earth is orange, it's a sun-kissed orange. So the moon is very small, like a red bean only, right? So it's much smaller, but because it's small, but it has a big area. The total area of the moon is big, So imagine it's possible that you have a buggy, what they call a Land Rover. You can explore the whole moon, front side and the far side. It's as if you explore the whole of North America and South America. So quite a lot of area, on the moon, right? So, but of course, the differences are the moon is smaller, gravity is weaker than the Earth, and has not much atmosphere. Of course, the very what they call sensitive equipment on the orbiters around the moon detected the moon has a very thin atmosphere of sodium atoms and potassium atoms. Why? Because you have what's called this solar wind, electrons and photons coming in at a high speed, hit the moon's surface, and also micrometeorites, the tiny dust particle will hit the moon and will kick up a lot of dust and also this sodium and potassium atoms. So it's a thin atmosphere. But for us, basically, practically it's a vacuum on the moon and moon surface. All right. So of course the moon is beautiful. Of course, in general, for history, in all civilization, the moon has affected the thinking of humanity. All kinds of romance, history, poetry, and so on. All right. So we hope that the moon also will inspire mankind to also explore the moon and the solar system in future. All right. So now it seems that, of course, looks like the Americans have the most promising project. So they have the SLS space launch system, most powerful rocket, not yet completed, even more powerful than Apollo Saturn V. All right. So that one will carry on, will bring to the moon the Orion spacecraft. And inside the Orion spacecraft, you have the lander that will land on the moon, hopefully in 2024. All right. So that's it. Anything
Okay.
else, Lisa? Michael?
Dr. Chong, so usually we often relate beautiful moon with the full moon. Always we have so many romantic
Yes.
things related to the full moon. But is it
Yeah.
actually the best time to view the moon during the full moon?
Yeah.
Or
Actually,
is other times?
it's a good question. So just to let you know that in Penang, we have been observing since 2016, car passing live every Saturday night. Maybe you say, sometimes we go there, we are lucky, you know, it's the 14th day of the lunar month or 15th day, full moon. Wow, so nice, the moon, I say very nice. But actually for us in astronomy, this is not a good time because let's say, this is actually on the 11th day of the lunar month where you have the dark side and the bright side. And tomorrow you find that the bright side will expand. So this line here, dividing the dark side and the bright side is called the terminator. Ladies and gentlemen, terminator here is not Arnold Schwarzenegger, Terminator movie. No, it's actually the shadow line divides the bright part and the left part. So as we go from 11 day, 12 day lunar month, so the moon becomes bigger and bigger. So now you find that later on, the whole moon will be fully lit on the 15th. So at that time on the 15th, the whole moon look like that. So if you go to the moon surface, you find there's no shadow. The sun is vertically up. So all the features don't have shadow. So for me, if let's say the weather is good in Penang tonight, where will I observe? We have seen the moon many times. Not here. You see, because of the fact that there is the sunlight is hitting the moon surface at a certain angle. So, ladies and gentlemen, by looking at this picture of the moon, you can tell the people who believe in the flat earth theory, remember? So a lot of people in the world, plus some of the people in Malaysia, believe that the earth is flat. So you show them the proof that the earth is not flat. By looking at this picture of the moon, you can prove that the moon is a sphere, not a flat surface. Why? Because if the moon is a flat surface, then here the sun will fall here. Then certainly the whole surface of the moon should also be equally lit. But it's not. Here bright, here less bright, because the moon is actually, this part of the moon is closest to the earth. This part of the moon is bulging towards the earth. This part of the moon is going away from the earth. Certainly this part of the moon is going away. So this proves that the moon is a sphere. So if you are on the moon looking at the earth, and you see the moon is, from the moon you look at the earth, you see a 11-day-old earth. 11-day-old earth. You also see on the earth a bright part, and then you have a dark part and the shadow. That picture of the earth from the moon will prove that the earth is not flat but round. So this proves that the moon is not flat but round. And so what we observe tonight, I would like to observe here, this is a sea of rainbow. I think China, they have landed some rover there some time ago in the sea of rainbow on the moon. So this is a part, if you look carefully, if you enlarge it, all right, you look at the sea, you look at here, this part here, you can see like the mountains, the valley pop out from the surface of the moon. 3D effect. So that's part we want to see. All right. So that's why we tell people Subgo is good lah. Good, romantic. But actually for us astronomy, not so good because all very flat. Right? But for us, for example, let's say if we want to observe a crater here today, no good. Because it's no shadow. All right. So what we want to do is 17-day-old moon, not 7-day-old moon, Chochat, or 3-quarter moon, 7-day-old moon, or third quarter, 21-day-old. In that case, the terminator will be from right across here. Right will be bright, left will be dark. Terminator is here, and then the crater you want to observe is right in the cut by the terminator. Then you can see that the crater got 3D effect. Right? So in other words, depending on what object you want to see, you have to wait. So let's say you want to observe here, better effect, maybe second day of the lunar month. Right? Here, third day of the lunar month, fourth day, seventh day, eighth day, ninth. Today is 11th day of the lunar month. All right. So like this. So anything else, Michael?
Yeah, the only time a full moon actually wows me is when I look through it with the binoculars.
Yes.
The 3D effect of a full moon brightly fill up the whole scene. Wow, it's really, really wow.
Yeah, yeah.
A bit, yeah.
Actually, Michael has stressed on a very important point. He said that you have seen the moon with the naked eye, with the telescope, but with the binoculars. With the
It's
binoculars,
different, totally different if you look through a
3D
binocular.
effect is that because it means like this. I make two comments. Michael's eyesight is very good. First comment. Now, the other one is in. The other one comment I'm making applies to everyone. Everyone who is a normal eyesight. Do you know that our human eye, inside our left eye, right eye, at the back of the eyeball, you have the retina, no? The rods and the cones, millions of the light sensitive cell. So actually, our human eye sensitivity, ability to detect small changes, is as good as any digital camera. So a human eye, don't look down human eye, Your eye is actually very, very powerful, very sensitive, right? Easily your eye is even better than many of the DSLR camera, right? The only thing is the DSLR camera, the light sensitivity may be better. But in terms of other things, the human eye don't play, is very good, right? In fact, some of the amateur astronomers, professional astronomers, they can, with their eye, they can see very, very dim objects which even the camera don't see so well. So that's why you said you see the moon is so good because your eye can see a lot of properties of the moon which normal camera cannot see. That's why you can see the 3D effect of the moon, right? So basically here, yeah. So if you will look at all the features here, sorry, Michael, 1 hour not enough. There's so many things to do. So I just like to end before I finish it. I'll end is that there are many boys and girls in the world. Boys and girls maybe say standard 5, standard 6, not standard 1, standard 2. Standard 5, standard 6 Malaysian age, Form 1, Form 2, of course, even in school, they actually are so keen on astronomy. Why? Because their father is an amateur astronomer, and their friends also have an astronomy club they join. They actually memorize with a big moon chart or the moon globe many of the objects on the moon. There are people in the world, even the kids, you show them a small crater, they'll tell you the name. I only know roughly about 100 features of the moon by sight. No need to refer to the book. But many people can memorize a lot. That is fantastic, right? That's good, right? So I think that's about all.
Okay, thank you, Dr. Chong, for your sharing. Yeah. So now we move on to William. Okay, William is going to explain to us how can we actually take a photo of the moon, and most importantly, how to take a good picture of the moon.
Don't need to emphasize the good. I can capture the moon. Yeah, okay. Hold on a second. From tell window, maybe. Okay. So hopefully my line is okay for my sharing.
So far so good.
Video very good.
You're just now so lagging. Okay, so I'll talk something so that to explain. First is when we want to focus photograph the moon is actually about half degree in the sky only, the apparent size of the angular size of the moon. So then you're gonna usually we will use this DSLR camera nowadays, digital SLR, and then maybe use a telephoto lens or telescope to photograph for the moon. So so that the focal length is important. If depends on how big the moon size you want to take. Okay, so this diagram shows you that. So you can notice that if you want to take a big moon like this one, you're gonna have a really long focal length telescope or telephoto lens. Okay, so but this one is the old reference. Okay, last time we only have the film, so then we refer to this. Now we have this one. So I think you still can find this program online somewhere in the internet. I'm not sure if still exists or not, but this one is really useful program. So you can just key in your the telescope or lens focal length here, somewhere around here, and then focal ratio and something like that, and then the camera you use. So then it will simulate the size of the moon that appear in your photograph. So it depends on how big the moon you want in your photograph. Then you can use this program to determine it. Either what type of camera to use or what type of telescope or lens to use. So you can use this program to do this. Okay, now it's very convenient. Last time we're gonna calculate ourselves.
Actually, even the smartphone apps also can do this. Can simulate.
Yeah, maybe. I'm not so sure about that.
Yeah, yes. Like the one, the Sky Safari, you can just put in your equipment and the camera combination and just display the appropriate field of view.
Also can choose various kind of camera.
Yes. Most common telescope and camera.
Yeah.
But you can also, how to say, the custom. I mean, if it's not in the list, but you know the spec, you can just key in the spec.
Yeah. So this is another example to show that if you use a 100 lens, then the moon size will be like that, and then if you have a 800 lens, then the moon will be very big. But this one is using this what we call the APS-C size of digital SLR. If you use a full frame SLR, this 800 moon will be slightly smaller because of the sensor size is different. Even though the lens, even though the lens focal length is not changed. Okay, so some people may think of if you want to use a telescope or telephoto lens to shoot the moon, but in my point of view is that I always use telescope to photograph the moon. Nearly unless I want the moon is very small, then only I use the lens. If I want the moon is very big like this, I will use only telescope. They got one reason because usually telephoto lens at this focal length will be very, very expensive and very, very big and also heavy. So then telescope is much cheaper, and then the focal length is much better, can be longer than telephoto lens, and then the effect is also better. So which one you want to choose? Usually I will use telescope. I think in my experience, I never use a telephoto lens like this. This is very big and then very expensive. I don't know on this one, but I have many telescopes. Means that if I have a budget to buy this telephoto lens, so in this case you will see that using a telescope is much what I call that. You can do many astrophoto rather than you just put your money on one lens only. So this is my opinion on this one. So choose a telescope is better than choosing a lens for lunar photography. Okay. So but this is one example that we're using this 300 telephoto lens. By that time, this one taken by frame, not digital. The moon is like that, so you can match with some landscape. This one is the latest image I took. This one is actually using a telescope, but the telescope focal length is only 400 so I can photograph the moon with the buildings like this. But now we have actually they do have one camera like called the Nikon P900. It actually can zoom up to 7 Yeah. So this one is so far the only compact camera that can zoom to the moon as this big. This is the photograph taken with this camera. So the only I think if you want the convenient one, maybe you can choose one of these, and then you can have the moon image like this.
What will be the difference
bigger?
What will be the difference in quality you use like this super zoom lens compared to a telescope? What will be the difference in terms of image quality? Is the lens better?
For lens, if you can find a good quality one, you might not see the difference. You might not see the difference. But most of the time, the telephoto lens, if the price is a cheaper one, then the quality will be much lower. If the high quality one, they will be really expensive. So that's the thing lah. The cost and performance ratio is not there for the lens. So for the telescope always can get the sharp moon compared with lens. But for this camera, with this result, actually is very good already. But the problem is this camera cannot snap a raw frame for the zoom like that. So you only you only can get the JPEG quality of this moon. So it depends on how high the quality you want. If you want the raw image of the moon, then you need to choose another type of camera, and then you mesh with a telescope. With a telescope, the price is relatively lower, and then the quality is there. It's much better than a telephoto lens. And the setup is much easier than the telephoto lens. Okay. Next, I will show you. Okay, this is the setup that I usually use. A telescope. Don't bother about this small telescope, but the main telescope here, the white color one, and behind has a DSLR. For this setup, also the same. Behind, I will attach the camera over here, a DSLR here, with a suitable T-ring for the camera. And then this is about the results when we shoot the moon. This is actually one of the event that I want to shoot the ISS transit across the moon. So this is the image from this telescope. This telescope, the focal length of this telescope is about 1,300 mm. So if you want the moon very big in your photograph, you're gonna choose the focal length longer one. Okay, then it can magnify the moon larger. Okay. So this is another example using the same setup of like this one, using the same setup like this one, 1,300 mm focal length. Then I can have the moon like that. I'm using a DSLR only at prime focus. And then this is a setting about that. This one shoot during between the twilight. The sky is not totally dark, so you still can see the moon. Okay? And this one using a smaller telescope, so the result is like that. DSLR with a small telescope. This one also the same, and this moon phase is very close to what you can see today. If you look outside with a telescope, then this is the moon phase that you can see. Then we also can use a mobile phone to take the photograph of the moon. You don't need to have an adapter for the mobile phone. You use your handheld behind the telescope, then you can take it already. So this is the example from the telescope here. This telescope, this is a DIY telescope actually. And then we just handheld our phone behind the eyepiece, and then we have the result like this. So you can see the crater and also some other features on the moon, very clear.
I have one question. I have one question about this handheld camera. So, yes. Have you ever tried to shoot with an iPhone?
iPhone, no.
Because it seems like the design of the iPhone camera is different from the other brand. Because usually when we handheld, we take a camera image, we usually put the camera close to the eyepiece surface. Right?
Yes.
But for iPhone, you have to back up a little bit. You cannot get close to the. I'm not sure why.
That depends on the eyepiece, and of course, the lens design also has the effect.
Because so far, I have tried on a different camera telescope. Try to take the moon and try to take the sun. If I put the iPhone camera close to the field of view is very small. You can see a dark ring at the side. So I have to back up a little bit, maybe by 1 cm or so. Then only I can get a nice full view of the image. I'm not sure why. I'm not sure whether it's because of the eyepiece or because of the iPhone. But other phone,
eyepiece
other phone is okay.
Yeah, actually, have the effect on that one. Sometimes you put the phone closer to the eyepiece, but some of the eyepiece you're gonna further away from the eyepiece, especially the wide angle eyepiece. The phone will gonna further away from the eyepiece. Then you can take better. If the close-up eyepiece means that the high magnification eyepiece, you can put your phone closer to the eyepiece.
Yeah, because I had this experience before during the same telescope. Because we are doing the stargazing. So one of the guys, he take the photo. I think he's using not Samsung, LG or whatever. So he put close. I can take very nice. But I try, I cannot. Same setup, same telescope, same eyepiece, but just different brand of camera.
Because
the phone
just different. And yours is the iPhone, right? Then the lens also make a difference.
I always have problem taking image with the iPhone through the telescope, so I give up already.
And your way you're gonna use.
Comment here.
Yeah.
Can comment?
Yeah. Yes.
So you see, most of the Malaysians, they are not aware that if you take a picture of the moon, you will not get the picture as you see here, right? Because in Malaysia, let's say you see on the crescent moon on the right, the curved part of the moon is not tilted, it's actually like the crescent actually pointing vertically downwards. So the crescent in Malaysia is always pointing vertically downwards towards the eastern horizon or towards the western horizon. So if you take a picture like that, so the crescent is slanted, it can be in Shanghai, can be in Italy. So if you see the crescent standing vertically, wow, you are in Norway. So be careful, So in other words, don't expect that everywhere in the world you take, it must look like that. So this is not in Malaysia. In equatorial region, the crescent always point downwards.
Unless you corrected the orientation, north-south orientation.
Because this is sand hill, sometimes our phone orientation also make the difference of the moon. Yeah, that's the thing. So this is also one of the example using mobile phone and handheld behind the telescope. And okay, if your hand is not steady enough, then you need to have some kind of adapter like this one. I think I have like this one. So you grab the phone over this phone grabber, and then you just align properly. Then you can make a better moon photograph by using this kind of setup behind a telescope. This is the example here. This is one of the example during this lunar eclipse. So yeah, this adapter very useful. Okay? And this is the example from the adapter. So you can see a clear, very sharp moon behind the telescope. I'm not sure if using lens can do this or not, but usually I use a telescope. And then almost never use lens to take a photograph of the moon at this peak.
Yes.
This is another example. This is a lunar eclipse. I use a mobile phone, then I capture this one using this one of the features of the mobile phone called the night mode. So you can capture the dark side of the shadow of the Earth and also the moon part over here. This is also another example using mobile phone also and behind the telescope, so you can get something like this.
Where was this taken, William?
This picture taken at Lombok.
Yeah, it'd be great if you had taken a whole video. Is it the rising moon or the setting moon?
It actually I cannot find
the video. Will be great, video.
This is a video. This is a video. Find the original video, so I only can show the.
Very nice.
Okay. But if nowadays the mobile phone can zoom very very high magnification, but then actually this is only the best moon you can shoot if you just purely using the mobile phone. Because the lens of the mobile phone is very small, so it actually cannot resolve the detail on the moon. Only the what you call that, the rough general features you can see, but not the detail like the crater you cannot see. Like that one. The way we can shoot the moon is using kind of camera we call the planetary camera. Usually this kind of camera design is for planetary use, and then it can magnify the moon bigger, and then can just take a particular features on the moon. So okay, this is one of the example that taken using this camera, the planetary camera here behind the telescope. Okay, but then you can zoom on the moon, and then you can capture something like this. This is actually a mosaic from 3 image. And I forgot which region of this moon already, but then it has a very nice what I call that, mountain train, and then
the top left hand side, William, is plateau.
Yeah.
So this is a northern region. The round.
This is the plateau.
The crater called plateau. Yeah.
This one, right?
Yeah. So northern region.
Yeah. So this is one of the example. We can have a closer magnify the moon bigger, and then have a closer observation through the imaging method. So this
William, sorry.
Yeah.
Can I butt in really quick?
Yeah.
You can take a photo of all these craters too using your cell phone, right? With the eyepiece.
Record it as a video.
I think actually
you have the photo stuff, right?
That I don't have that photo.
Oh, you don't have. Okay, but it's doable, right? We can do that.
Yes.
Because if you have a high enough magnification, you can just stick
it's actually possible. Yes. Yeah,
photos.
the way that we shoot this what you call that, the lunar features is very much similar to the one. I want to log into my Facebook and then show you the video. One of the video that I take using this planetary camera, not a mobile phone, but mobile. If we can have an adapter for the mobile phone and then we attach behind the camera, that will be that. Then you can do that. Yeah, you can image as same as this planetary camera.
But nowadays, the mobile phone, the sensor chip also is not much smaller than the planetary camera, like just maybe half.
The only downside is that you gonna go through this mobile phone lens, and you're not so sure about the quality of the mobile phone, the lens quality of the mobile phone. So
not direct to the sensor.
yeah, that's the thing. And then you go through so many optical surface, and then the image more or less will downgrade a little bit.
I think for moon, it still be okay, like because moon is still bright. But for planet, maybe not.
Yeah.
Unless you are very particular with the details, then you can see the difference.
Yeah, true. That one's true also. Okay, now I still share my this screen here. I think it's this one. So you can see. So this is taken using this planetary camera. If for mobile phone, it's the same way. So you just record the video, a video clip of this one, and then we process it using software, and we can make it better than only a single shot. So you can see the moon is moving around because of this our atmosphere disturbance. So it make it not stable, always moving like that. This is one of the when the camera is recording, the image become black and white. So, like save more space for the file, something like that. So you can see the moon is always moving, so like it's always moving, but actually this is our Earth atmosphere. That's from our Earth atmosphere. So mobile phone, maybe I will try someday. I never think to try that one, but yeah, I think
see the comparison. What's the big difference?
Yeah.
I've done it before, but I don't know where the photos have gone. But it's doable, and I was actually waiting to see, and it looks almost similar to your planetary camera photos. Actually, I think your planetary camera photos are much sharper because
I have the
it was
I have
years ago.
Actually, I had the example of Saturn, but not the moon. Maybe later I
have too, but it's not very impressive. Like it's just this tiny little with this tiny little ring there. Yeah, it's tiny. Yeah. Nothing like what your camera and setup can capture.
Yeah, basically, if you have this planetary camera, is much better. Yeah, and also you know the video format of the mobile phone is only up to H.264 or perhaps some other format, but sure it not the uncompressed format. Usually mobile phone will be compressed, so the detail will lost over there. But for planetary camera, we can record uncompressed video file. So the one video file is very big. If you take about 30 seconds, maybe you need will eat up your space like about 3 gigabyte or 5 gigabyte. Yeah, only 30 seconds. So the detail will be more over there. So mobile phone might not can compare with this in this kind of perspective. Yeah. So I think this is what I would like to share.
Okay. So thank you, William, for your sharing. So okay, now we move on to
question for William. Yeah. Two questions, one general question, one specific. The general one is, I'm sure some of the Malaysians who observe, they are keen, they want to learn astronomy, want to do astronomy. Imagine there's a young Malaysian, just graduated about 2-3 years ago from college, start working 2-3 years, and want to take up astronomy as a hobby. So what type of telescope for beginners, you can recommend to take pictures of the moon, what type of camera for a beginner, and if they have extra budget, the Planetary Camera. What type of budget for this beginner?
For telescope, actually, not easy to recommend. Not easy to recommend because
Yeah, because some people say they want to buy a telescope for their kids, for their boyfriend, girlfriend. They say, what you want to see? You say, oh, I want to look at the moon, I want to look at the planet, I want to look at this kind of object. But what the big range? You want to look at everything, with a small telescope.
yeah, that is. I own many types of telescope. Why is that so? Because one telescope cannot do all kinds of observation. So for example here, if you can see here, oh sorry, okay, where's my issue? Okay, so actually I would like to if for the moon only, for the moon photograph, this kind of telescope is quite good already. This is a 4-inch from 90 mm to 127 mm was the diameter of the telescope. But then I choose the one is the 100 mm telescope, the diameter of the telescope. That will be enough already for the lunar photography. And in case of this camera, whatever camera, DSLR camera that is the cheapest, then you can use, regardless about the brand. Any DSLR camera you can use to attach behind this telescope, and then you can do the lunar photography. If for the planetary camera, also the same. Look for the cheapest planetary camera. Then you can do the simple lunar imaging like this one here. So you can do that already. So the only thing you're gonna choose is a telescope. The telescope, maybe this kind of telescope, then will last longer for any kind of the observation, not only for the moon. I think roughly like that.
So now, William, I have my specific question. Since you have taken so many moon pictures, why not you go up one step higher? You come up with your own, what they call survey of the moon, very high detail picture of the whole moon. Just example is, many years ago, I was in Singapore. I met Albert Lim. Albert Lim used the Singapore Science Center telescope, photographic atlas of the moon. It came up and published by Cambridge University Press. So why not you go higher? You take good pictures of the moon and come up with your own atlas. Whether you publish or not is up to you. But then you can say that the more detailed pictures of the moon is taken by our William Chin from KL. Give it that. When you are doing your nebula and so on, when you have free time, take the moon. Then you finally, after some years, you have your own photographic atlas of the moon. Detailed one. Yeah.
Your current 200.
Yeah. And then I asked Albert one question. But what is the problem with the moon? He said, taking picture of the moon is easy. Even you have a light layer of cloud, you can still take excellent picture of the moon. So that's why they focus on the moon. And it was published by Cambridge University Press, So why not you come up with your own atlas? Be serious. Yeah, like this. That's my suggestion.
Yeah. Hopefully got time in the future for this.
Get William Optics to publish it. So there will be William's Atlas of the Moon, and it's William on both sides. Right?
Yeah. And second, you can say, put in your acknowledgement, it's taken from my house, where behind my house got coconut trees. Got coconut trees. Not necessarily you must take it where you have a big observatory next to your house, you have the pine forest. No, behind your house got coconut tree, got durian trees. You can put it like that lah. Yeah.
Okay. Okay. Thank you, William, for your sharing on the imaging. So now we move on to Derek. Okay, what are you going to share with us today?
Yeah. So I think that sort of a small conclusion, like for the whole talk. So, I totally agree with William that telephoto lens is, not sufficient for good moon photo. So and when I say good, what I'm talking about is being able to go in deep to see, like high resolution detail of the craters and stuff. So may I share my screen? I just share one photo really quickly. Okay, just show you the best photo I can get. Okay, the best photo I can get of the moon. Okay, this guy, Sigma 150 to 600, with a 2x converter, so 1200 millimeters. Okay, this is as large as I can get it. All right, no further, and the problem is the focal length. Okay, so just want to add that, and you know, so I think that one pertinent question for many people is like, why do we want to look at the moon anyways, right? So I think that in general, first of all, the moon is actually very easy to observe. Okay, can you all hear me clearly? So,
Yeah, I can hear you, but cannot see
okay.
you.
Oh, you cannot see me. Oh,
Yeah.
I'm sorry. I think the video went off. Okay, apologize. So it is easy to observe. It is the most directly astronomical thing other than the sun. Okay, so you follow the moon, and then there's Venus, and you know, all the planets, right? And actually, you know, just going in deeper, right? What Dr. Chong mentioned earlier, okay, is when we look at the moon. Okay, I mean, when you look at the moon through a telescope, you know, don't feel like you just, oh yeah, it's the moon. You know, okay, that's it, just a piece of rock in the sky. You know, but this piece of rock has a significance, right? Because it acts like a mirror to the Earth. Okay, what kind of mirror? It's almost like we see ourselves in the moon. Why? Because the most popular theory of how the moon formed was an impact between the Earth and the moon many billions of years ago. Okay, and the moon reflects the nature of the Earth back then. And the other thing is the Earth experiences a lot of this wind, rain, and everything, so it washes away a lot of details from the surface of the Earth. But if you look at the moon, it's pretty much permanent. Okay, a meteorite hits, that crater will stay there. Okay, and if we kind of are able to trace like the lifetime of the formation of the craters and the moraines and everything, you could kind of get a historical timeline of what really happened in our solar system back then. Okay, so it also helps us, you know, by studying moon rocks, and Dr. Chong also alluded to it, that, you know, there'll be meteorites that hit the moon, and then it sticks up. I mean, there'll be projectile, there'll be ejector from the explosion, and then that ejector would actually fly around in orbit, and then actually land on Earth. Okay, so there are actually moon rocks on Earth, but I'm not sure how. You know, they're probably pretty rare. Okay, and if you find one, you'll probably be rich. All right. Now, there's also another important aspect to observing the moon. Like when we talk about observing the moon, you know, we just keep saying that, oh, we need a telescope to look at it. We need the binoculars. Yes, it's beautiful and everything. Okay, but if you just look at the relationship between the moon and the tides, okay, high tide versus the time of the new moon and the full moon, okay, you really notice a pattern, right? And is the reason is because the moon's gravitational effect on Earth and how it actually causes the tides. And in fact, life on Earth probably owes its existence to the moon, because the moon itself, when it creates the tide, and there's speculation, okay, it is not real, really proven, but there's reason to believe that the tides are what kind of cause life to evolve from a transition from the water to land. Okay, because when the tides come, the land is covered by water, and then when the tides recede, okay, these animals, they learn to breathe on land and slowly come onto land. Okay, so these are a lot of ways, you know, other ways to observe the moon. Okay, if you observe the moon over a long period of time, you also notice it goes through its phases. If you observe the moon during a lunar eclipse, and you know, okay, during the lunar eclipse, you can see the shadow of the Earth. Yeah, it is actually round. So, you know, of course, the flat earthers will tell you it's a flat plate. Yeah, and so you can't argue with that, sort of. Okay, but at least you know that the Earth is round. And you got to go to Aristotle to kind of, said Aristotle, measure the length, the radius of the Earth there, back in how many BC, to kind of really tell the Earth is round. But back to the moon. Okay, there's really a lot of things that we can infer from the existence of the moon. So I think that Dr. Chong explained the science of the moon. William explained how to observe it, how to photograph it nicely. But I think that just as a kind of closing, we need to appreciate the moon deeper. Okay, it's always there. You always see it. Okay, there's clouds out. There's the moon. All right. It actually has a lot of effect on us. Okay. I think that there's also a lot of scientific research too that study how animals behave through the full moon and during non-full moon. Okay, so I think that even when you're not really, when you're going out, I mean, a lot of people who like to take photos of the moon are probably photographers too. Okay, and maybe you don't want to invest in a telescope. And then you say that, okay, I'm gonna do ordinary telephoto moon photography. But when you go out and take macro photography at night, okay, do you actually observe what the phase of the moon is, and how do the insects or the snakes or the bats that you are taking photograph of, the owls, okay, how do they behave during the phases of the moon? Okay, so again, what I'm sort of telling is, like, instead of just visual detail observing of the moon, make it a more holistic thing. Instead of just space, expand it into time. Okay, observe the moon not through just a specific detail, specific spot, but as a function of time as well. How does it change? Okay, there's it ranges from even transient lunar phenomena. Some people look at the moon and then suddenly they see a flash of light. That's probably a meteor hitting the moon, and you happen to see it. Okay, these are also recorded. So it ranges from that short period to the tides, to many, many years. The tidal effect of the moon, interaction with the Earth. The moon is getting further and further from the Earth, but about as fast as your fingernails grow. Okay, so it's completely fascinating. All right, the moon is more than meets the eye. Okay, and I think that's kind of how I'll conclude this session. Okay.
Yeah, right.
Add a general comment, Michael, to what our Derek has said. So basically, in Penang, sometimes we do observation, and there's a little boy, say standard 3, standard 4, ask the whole night asking about the moon. You're looking at the moon. Then later on, I want to say, now I want to impress your little boy that it's more than what you can see, right? Because there's a picture here. For example, you can see. Wait, I'll wait a minute. Wait a minute. Present now. Okay, you see this picture, the moon and the Earth? Can see, huh?
Yeah.
Okay, so basically, do you know that in the textbook it's quoted that the Earth spins on its axis once a day, and the moon orbits the Earth once a month. But because of the presence of the moon, the moon's orbit around the Earth, actually there's a force of gravity of the moon pulling on the Earth, and of course Earth pulling on the moon. But now we are talking about the moon pulling on the Earth, because the moon's gravity pulling on the Earth, it stabilizes the spin axis of the Earth. It has been proven. All right. So imagine that there is a case where Earth don't have a moon, only the Earth spin on axis, because there's no moon pulling on the Earth. So the Earth spin axis can, over a longer period of time, hundreds of millions, it become chaotic. Right now, the Earth's axis point like this, 23.5 degrees pointing this way. But in future, if there's no moon, the axis will point different directions. So the axis will become chaotic. Imagine the Earth has a spin axis that become chaotic. Do you think life will exist? No, because you have summer, winter, autumn, all kalam kabut. So very unlikely to have life. And because of the presence of the moon, the Earth's spin axis is stabilized. That's why it's very consistent that year after year, you have autumn, winter, summer, spring, comes like a natural cycle, all right? Because of the presence of the moon. So if the moon is not there, maybe life cannot exist on the moon because it become chaotic. Earth spin exists. So I'll tell the little boy. So now you know why. I say I'll just add on that because of the moon is up there, we are here. Life is possible on the Earth. So we have to thank the moon for that. Okay, thank you. That's all.
Okay, thank you, Dr. Chong. Thank you, William. Also, thank you to Derek for your sharing. Okay, very informative sharing tonight. Okay, in conjunction with the Observe the Moon, International Observe the Moon Night, okay, 2020. But seems like we don't really have a chance to look at the moon tonight. Okay, how is the sky there, William?
Cloud gazing. Cloud gazing in Malaysia is cloud gazing.
Total eclipse.
Water nebula.
Yeah.
It's
nice. The moon is brighter.
Yeah, much better than just now.
Just now I'm thinking of setting up quickly, but then I think my equipment just put there and there, here and there. So no time to actually can assemble your telescope outside there.
Okay, for those of us,
Yeah.
okay, if you have a clear sky at your place, okay, if you have a telescope or without telescope or just with your eyes, go outside and look at the moon and appreciate the moon and thank the moon for what we are today. Okay, without the moon, we won't be here talking to you.
Yeah.
One more final comment. When you look at the moon, appreciate the moon, we're actually appreciating the moon and the sun.
Yeah.
It's actually the sunlight falling on the moon and scatter back to the earth. So we're appreciating the moon and the sun at the same time. Okay.
Without the moonlight, I think there will be quite a big difference in life on Earth. Yeah.
Yeah. And we were not talking about the moon now.
Yeah, because it's no light here, nobody will notice.
I just realized that now there is a moon halo.
Yeah.
I just realized there's a moon halo.
You can see the halo.
Yeah.
Oh, yeah.
You can see.
Wow, even though I can see the halo.
Can see.
I never think that tonight can have observation because of the weather.
Oh, look at that.
Wow.
You see?
Yeah.
You see so many clouds here.
Yeah.
Okay, this is the one the hole between the clouds. So
Yeah.
okay. Yeah.
Okay, so I think we can stop here for today. Okay, thanks again to our panel. Okay, Dr. Chong, William, and also Derek. Okay, and also thanks to everyone who have been joining us today. So see you again next time. Good night.
Thank you, Michael, William,
Thank you.
and
Thank you.
Hope you have.
Thank you, everyone.
Thank you, Michael.
Okay.
Thank you, everyone.
Okay. Yes.